Ladies and gentlemen, may we cordially invite on stage Yang Berbahagia Tan Sri Datuk Clifford Herbert to introduce our keynote speaker, Mr. Goh Peng Ooi.
First, good morning. A very, very good morning to each and every one of you. From here, I can see you're all looking very bright and cheerful and smiling. Can you all laugh? Okay, great. And this morning, actually, we are privileged. We are very happy to have with us Mr. Goh Peng Ooi. And if you read your book, which you have on page 14, you will find that Forbes describes him as a tech billionaire. Now, what that means, I don't know. You have to ask him. And he's, I think, really a tech entrepreneur. He's the founder of Silver Lake Exists, and he just told me Silver Lake has 128 companies, and they are expanding in 100 countries. So you can see down there the dimensions of it. No, it's vast, no? It's tremendously vast, and really, Mr. Goh really heads this down there. And if you listen to him, I was listening to him just now, a very impressive man. Half of it I didn't understand. I hope you will understand, and I'm sure he will make you understand. I'm going to ask him to talk about half an hour, and then open it up to questions. You know. So, sir, can you start, sir?
So the topic of the focus of the talk is on things like economy, fourth industrial revolution, entrepreneurship, and methodology. Now, why we talk about methodology? It is actually because we tend to talk things without referencing point. And without referencing point, actually, frankly, you do not have cohesiveness. You will never come to agreement. And that was well said by Louis Wittgenstein. Louis Wittgenstein said, knowledge is to be acknowledged. So you can exert any knowledge, but it has to be acknowledged. Then that acknowledgement needs knowledge, and further needs acknowledgement. So you get into a paradox that you never end. So without a starting point, you never end. Now we always have this word called first principle. Now first principle, like for example, birds of same feathers flock together. Birds of a feather. I don't know why a feather. So I always said birds of same feathers. And we have different first principles. Honesty is the best policy, and so on and so forth. And we really have to test those first principles. And that, well, I think for common use, it is a very powerful tool. It's a very powerful tool to see whether we are cohesive, whether we agree with each other, whether we agree with each other on the first principle. Right? For example, current trade war between China and US is actually about whether it's bilateral or whether it is willing buyer, willing seller, multilateral. Right? And now the first principle is bilateral works, or willing buyer, willing seller, multilateral works. Now you can argue both sides anyway. Both camps would definitely come to the same conclusion. One would support multilateral, the other one would support bilateral. But don't worry about the conclusion. Time tells. Time tells. There will always be a conclusion. Human being can't conclude, God can conclude. Now, so methodology is very important. And so the word God concludes, is it true or not true? Actually, it's true. Otherwise, we couldn't do anything. Right? If we look at the neutron star colliding, if they are not going to conclude, what are you going to look at? And neutron stars are massive. Now, and what about black holes? How are you going to see black hole when they are completely black? Well, that you can, because they can't be completely black, because black hole is not God. It can't be completely black because the background light will seep through where it can't influence. Black hole is huge. Well, about 6 billion suns. 6 billion suns is an unthinkable numbers to us. Yet, light can pass through from the very edge of black hole. Why? Because black hole, even so massive and powerful, is not God. But finally, everything concludes so that we can see, and we call that order. Right? So, while we, in human history, we tried many things. We call it first principle, we call it axioms. Now, the new one that was discovered in 1941 is actually something called category. Or, if you want to make it a bit simpler, actually that principle of thought was shockingly discovered in Islamic world. And it was actually discovered in 880 by Al-Khwarizmi. And we call that algebra. Right? And so if you trace back, we have another word which is nearly equivalent to category. It's called symmetry, which is much nicer word, much easier, friendly. And that's why in Civic logo, you find that there's a word called symmetry at work. Now, it's to make sure we don't have to use difficult word. And if you press me a bit harder, I will use the word category. Otherwise, I'll retreat to symmetry. Then I will use, somehow, our people, maybe whoever, shows the snow crystals there, and all the symmetries, patterns there. Now, if you go to Islamic world and you take a photo of all mosques, you'll find that all design of mosque arises from a ruler, a compass, and that's it. And that's it. Okay, a ruler and a compass. Now, so if you ask how, well, there is a good videos somewhere in the YouTube. You actually can look at how you create all patterns of things that we don't even know back in 1950s. For example, there's a mosque in Isfahan that actually shows us something called Primrose design. And you know, Roger Primrose got a Nobel Prize back in for the Penrose design in 1966. And maybe the year is wrong. Anyway, I don't intend to be exact. That one I think you can check in Google. So there are methodology called symmetry. Symmetry. Now, actually, the technical word is called category. Now, so indirectly, we are saying that our methodology is category. So the way we talk is category. Now, okay, now, having a methodology unites people. At least, whether we are far away from the methodology or whether are close to the methodology, there are measurements. Now, what is the purpose of our measurements? It depends on what you want to do. And of course, one of the purposes is actually about researchers. Now, Civic is actually a research company. Now, it is always misunderstood that researchers are poor. Why should researchers be poor? The first principle of researchers are poor is wrong. And I have proven that researchers need not be poor. So I prove that that first principle is wrong. So researchers need not be poor, so they can be economical. Right? So the second thing about what we want to do is economy. Now, but you have thousands of people Now, who would actually work together with you as researchers in one form or another. Now, so how are you going to unite them? Now, number one, of course, you apply a methodology. But the problem about methodology is that how many people can understand them? Now, category theory was accidentally discovered. It shows how difficult the theory is. In 1941, by Eilenberg and MacLean. And the mathematicians argue over this issue for 30 years, which means it's a headache problem. Right? So now how you unite people towards an economic end when you are talking about a subject that mathematicians have headaches? Now the answer is actually very simple, because in economy we deal with least imperfection. Now a good example of least imperfection is what we always said, that the last batch of the last part of a class. Okay, let's divide the class into A class, B class, C class. The C class, A class become professors and academics and administrators. But the B class and engineers, right? The B class become their managers. And the C class become the politicians and manage all the managers and the engineers, right? Now, then you have this problem, is the world upside down? So is it the world is wrong? Or God somehow got crazy? No, it's not true. There are two measurements. They are not one measurement. Now, unfortunately, our education has focused on only one measurement. That is, was, and is capability. Okay. Now, to understand what is a capability, let's talk about a river stream. A stream or a river. Now, a stream ages its rocks. You know, give it time. Stream can age a rock. And a good example is Japanese. They are not the brightest, but when it comes to making perfect things, they are so-called damn very perfect. Okay. Now, it's because of the patience they age through the hard rocks. But on the other hand, so that is called capability. But what about the river will flow into the dam? Right, go into the dam. And now the dam, of course, has a different purpose, different economic purposes. It generates electricity, it provides water supply. It's different from a stream. So what do you call that? What economic purpose? How you measure that economic purpose? It's called capacity. Now we measure electricity production, water consumption. We measure telecommunication. We measure those things by capacities. Now, give a good example of, and that actually is the key point that I want to emphasize, that the world has moved on from capability world into a capacity world. So, good example is Google. Google, I can beat Google in capability. I can design technology better than Google, but I can't beat them in capacity. I can beat Alibaba in capability, but I can't beat Alibaba in capacity. So, born a Malaysian, I knew I can't beat big nations' capacity. Now, one choice is migrate. Go there, beat them. But if you refuse to migrate, don't even think about beating them. Because that capacity does not belong to you. So you look at Facebook, it's using the capacity to do advertisement. So it's the water flowing to the dam being used to produce electricity, which is completely different purpose from the original capability of a river. or a stream. Right? So Facebook, you thought how Facebook is going to make money? Oh, they sell advertisement, they do things which are completely nothing to do with the original capability. Nothing to do with the original capability, whether it's Google, whether it's Uber, whether it's Alibaba, whether it's Tencent, all the same. Proven that we are moving to a world of capacity. Now, so, well, we have in a way broadly covered every topic about methodology, economy. Now, we haven't talked about fourth industrial revolution, but we have talked about entrepreneurship, because Google is entrepreneurship, you know, Facebook is entrepreneurship, Alibaba is entrepreneurship, and entrepreneurship today is about moving from capability to capacity, rather than I have seen many people asking me to invest. I've met a lot of them, but the problem, all of them talk about capability. Now, that is unfortunately how we train our kids. We train them to be individualistic. We train them to be, I'm the greatest. But if you are the greatest, you are alone. Sorry, too bad. Now, unless you can coagulate, you can make things cohesive. Otherwise, you better be a doctor or architect. But don't try to be an entrepreneur. If you want to be greatest, or another profession, mathematicians. Okay? And my problem with mathematicians, good friends, is they dare not talk about economy. We can talk 5 hours. When I talk about economy, their face turned. They thought I betrayed them. You know, to them, I'm a betrayer. You know, a mathematician who talk money is a betrayer to mathematics. No, but you defeat yourself. You right from the start, you defeat yourself. What is money? Money is mapping. Money is mapping. So we also teach mathematics wrong right from the first day. We ask our kid to remember 1 + 1 = 2. And a very intelligent kid asks you, what is equal? And you look at him and you don't know how to answer. And then some kids say, no, my father plus my mother plus me is 3. Now, you say he's wrong. You are killing his creativity. He actually looked at his own life. My father plus my mother plus equal to me, therefore 3, plus, of course, 1 + 1 = me, and then 3, right? So equal to 3, the family has 3, right? The end result is 3, it's not 2. So you say, no, you are wrong, and then a big cross. Now what happened? He will become more and more like Singaporean, okay? And very obsessive. You know, they will, you know, I openly tell Singaporean, you know, you are fantastic, you know, you are rule obeying, but watch out, you're not God, okay? When you obey rules, you obey to God's rule, not just human rule. God rules governs all rules. Okay, so when you obey rules, you obey all rules, not just one rule. And Malaysian has Malaysian rules, Philippines has Philippine rules. If you want to operate in 100 countries, you better obey 100 countries' rule. And that's the reality. That is not trying to be nice. That's the reality I face. And you know, nowadays we talk about taxes. Every country wants to look at your taxes. You know, it's not just Malaysia. Every country very interested in your taxes. Okay? No country say no. Okay? Now, so that these are very real things. These are not fake. And this is part of entrepreneurship, the respect for systems. You know, the ability to do compliance. Now, so we broadly covered the 3 topics of entrepreneurship, economy, methodology. We leave out 4th industrial revolution, which is very difficult because, so why industrial revolution? Now, for thousands of years, we live actually not much different because our capability remain, as human beings, remain not much change. Those farmers remain farmers, hunters remain hunters. We improve a bit by building some houses, some palaces, some pyramids, but we use tens of thousands, maybe hundreds of thousands. And the Great Wall of China was millions of people died in construction of Great Wall of China. So those were the days of using brute force to build what we want. Now, so one day, there was a person who looked at an apple and asked why apple fell down. Okay, so he finally, as we improve his work, now we have a very simple mathematical equation. F equal to mdVdt or dmvdt. Now, in Form 5, Form 6, we say F equal to ma. Now, for completeness sake, the proper equation is F equal to dmvdt. That means if mass change, velocity change with time, then certain forces will be released, and that you have rocket, you have, from there you can actually calculate masses of stellar bodies. So that was called mechanics. Now, here I want to point a very important point about methodology. I tried to gather all the texts of mechanics, hydraulic engineering, and all the engineering, architecture, and so on, and you find that, if you're going to collect just all the images, you are going to have many, many of them. And if you're going to buy those textbooks, you are going to fill up from one end of the room to the other end of the room, maybe go back again. And that's how massive is mechanics. Yet when you present it in a mathematical form, it's F equal to dmvdt. You can talk about rocket sciences, you can talk about astrology, you can talk about your house, you can talk about the flow of the river, you can talk about the strength of steel, you can talk about anything. It boils down to a simple equation, F equal to dmvdt. Who wrote those equations? One, Al-Khwarizmi. And now, it's important that we always take bias out from our mind. Algebra was witchcraft until 1850. Just in case you thought it was willingly accepted by Christian societies. Obviously, I'm not going to accept anything from the other religion, right? It's very obvious. I mean, there's no reason any religion will accept the other religion's invention. I'm not talking about whichever side. They just don't agree with each other. Disagreement for the sake of disagreement. Okay? Now, it's called bias. It took until 1850. Hamilton, actually, who propagated algebra. Now, before that, if you do algebra, you could have your head cut off. And that explained, which was one of the questions I asked when I was young, why this stupid Newton, who invented calculus, refused to use calculus to write his laws of motion. And I hate that, a person who can write mathematics wrote difficult English. Law of motion. Do you know it was written in Latin and no equation? And yet he was a father of calculus. Why? During his time, if he did that, so finally I found out that, he would have his head chopped off if he actually wrote a calculus equation, which is mdVdt. And he could easily wrote that equation. So it's interesting, right? How we prevent our own progress, right? And it's called bias. Now, so that, of course, is called First Industrial Revolution, right? Now, with that, we went into the second phase, and it started from light, the study of light. And of course, thunders and static electricity, so on, give us a hint there's something else called electricity. And when we heat up objects, it glows. So we know it has some relationship between matter, light, and electricity, because when we touch something, we actually get shocked. It's called static electricity. And so somehow people start trying to associate. Now, it's a very important word, associate. In the mathematics, this is a very, very important word. It's called associativeness. Now, when they start to associate all these phenomena, finally you get into electromagnetism. They are natural magnets. So actually, you will finally reach the point called electromagnetism, and Maxwell was the one who consolidated all the equations into four, and one is static electricity, the other one is static magnetism, the other one is the flow of electricity, the fourth one is the flow of magnetic field. It's as simple as that, and that basically four equations. And we call that Second Industrial Revolution. Now look at what happened after that: electric car, electric generation, then you start have lights, and you have everything about electricity and magnetic things. So when was Third Industrial Revolution? Now, Third Industrial Revolution has a lot to do with algebra. So we reach a point that when we look at electromagnetism and we look at mechanics, we actually hit lots of limits that we can't actually overcome. And we overcame those limits by something called quantum method. Now, so what is quantum theory? And if you ask around, I can guarantee you're going to get as many answers as the professors you ask. I don't know whether there's a professor who is brave enough to say quantum theory is all about group and semi-group. Now, I believe there are a lot of them. Richard Feynman, Yang Zhenning. Now, these are people, Herman Weyl. Now, these are people who work on symmetry. Now, symmetry started, the word symmetry, of course, was used in the days of the Greek, and then by the Muslim scholars. Then, of course, in 1953, Herman Weyl actually sort of convert this so-called quantum phenomena, which is so difficult to explain to anyone, into one word that you can actually take home and feel comfortable, and that was called symmetry. It's about balances, it's about the right proportion, it's about harmony, and we're wondering what the heck science talking about harmony, balances. Well, if you believe in God, you need order. Order is about balances, it's about harmony, it's about the right proportion. Is a lot of things that human beings use, but actually in single word, you could have just called it order. Now, of course, if you want to penetrate further, You have to discover higher order. You just can't repeat the same trick. Okay, and expect different result. That was what Einstein said. Don't repeat the same trick, but expect the same result. So of course you need to somehow do a quantum jump, right? The quantum leap. Well, they just found quantum leap, right? They just discovered quantum leap. The word quantum leap was also vague. They just discovered that. That was like a week ago. Okay, so you need to do quantum leap. Now, but if you read quantum theory, there are so many equations until you get headache. You get headache that you really think that it is a topic that you really don't want to learn. But you'll be shocked. Quantum theory is actually very simple. It is all about complex number. And it is so simple that you can actually get bored. It is about one part of complex number. That means you introduce an imaginary. Right? If you are you are electrical engineer, you use the word, the complex number J as a current flow, right? J omega, and basically J omega means magnetic flow or electricity flow. So 1 plus IB is a real number with an imaginary number. Now, but human being can't deal with anything imaginary, so you have to multiply it with A minus IB. Then you get A squared plus B squared, you get something real. And that's how we see quantum phenomena. We play all the virtual equations. Finally, actually, we multiply. That's why we have this equation called psi. So A psi. Now, quantum physics is all about psi A psi. Now, the two psi multiplied by together is called psi squared equal to 1. That means it will happen. Right? A squared plus B squared, it will happen, right? Like A plus IB multiplied by A minus IB, all of them are imaginary. What the heck they are, don't know. But when you multiply together, it's called A squared plus B squared, means real, right? So therefore, it will happen. Now, so if you express in Schrödinger equation, it becomes psi A psi, or CAC, how depend on how you pronounce it, PSI. Okay, so that was the third industrial revolution, that we jump over electricity, we jump over mechanics. Now, the question is, what is fourth industrial revolution? This one is tough. So I'm going to go through one chart. Okay. I will try to point to you this one. Now this equation, this group of equation was presented in 2006. Sigma dot 1F equal to sigma dot G bracket dot F equal to sigma dot G dot bracket. Now, and if sigma element of X F2, I hope it is correctly written there, element of, okay, if sigma is an element of a set that we call C set, which is this big X is called C set. The good news is when you call it a set, it means you know. When any mathematician can call it a set, it means a layman can understand. Okay? So sigma, if it's an element of a C set with of F2, it should be a small character there, F2. I don't know why the equation, the F1, F2 has disappeared. Okay, I know why. Because use the apostrophe, so the difference is the apostrophe. So this is F2, this is F1, so F1 transfer to F2 through F transformation, and it belongs to category theory, implies that it has to be like this. Now, let me quickly use a theology term to explain. Okay, so then you can see it is very easy, and then we can actually more or less conclude, actually the world is very orderly. It's not that complex, and it's not that messy as we thought. Okay, and with this, then we can close I think it's better to do question and answer, because you can actually go on and on and on and on. This chart finally leads to thousands and thousands of pages of charts that I have wrote over the last 30 years, until I got so fed up that I don't even have time to sort it out. Now, God created everything. Now, again, this F should be a small f, so should be a suffix. So, assuming God creates everything, right? So God is sigma, creates everything. In mathematics, we call it natural transformation. In computer engineering, we actually use eta, like n, eta. Okay, so we don't use, engineers dislike mathematicians, so they purposely create another symbol. And one professor argued with me, it's eta. I said, okay, it's eta because you are an engineer, okay? But it was created by the mathematician, okay? So assuming sigma, natural transformation, mathematicians don't want to talk about God because they are so worried being used by people to quarrel. So they said, God creates everything, and we call that everything one. And that is could read as identity. God creates all identities. All identities. All identities. Atom identities. You identities. Camera identities. Water identities. God creates all identity. In layman language, God creates everything. Okay, who say that? Not God, human being. So we put an F there. F represents human being. So God creates everything. Who said this? Not God. Human being said this. But whichever way, whoever said it, it doesn't matter. It's equal to God, okay? Now that is basically the first assumption. Sigma dot 1F equal to sigma. You ask me why they do this. I said it's 2,500 years of mathematics. In order to get it together, to make sure everything works, you just have to do this. If you are not going to you're not going to recognize the word called identity, don't talk mathematics, because everything fails. So we have to create this word called identity. So how we created this word called identity is sigma dot 1F equal to sigma. God don't want me to fall down, okay? Now, second, assuming that we created the term identity, now, but there are a lot of phenomena. Now, we tend to look at phenomena from object point of view. That means from things point of view. We tend to disrespect how God look at it. We tend to say, I am I, you are you. But the way God look at you is that all of you are human beings. You are human being 1, you are human being 2, you are human being 3. So the looking at you is called, how God look at you is called G, F. Now you find that we intentionally put G before F. Why? Because human being look at F before G. Right? Human being said F come before G. Now God comes from the other side, say no, G come before F. That's why sigma dot G bracket dot F equal to sigma dot G dot F. Now you ask me, are you creating a story? The answer is no. If we don't do that, all our mathematics fail. It's not because we want to do it. If we don't do that, all our mathematics fail. So we have no choice. While we can tell you the story, but the truth we tell you the story is because we can't come up with another story. Right? So, telling you the story is to make it easy, but actually we can't come up with another story. Now, so if you have that, then you can see there's another way of looking at things. Now we call it think out of the box. Right? It's actually see from God's point of view. Don't worry about whether you believe or you don't believe. Just look from nature's point of view. If you really don't believe in God, just see from nature's point of view. You know, does nature care who you are? No, doesn't care. You try to drown yourself, sure guaranteed. They'll guarantee you drown, okay? No, doesn't care who you are, okay? Like I always said, you know, if you want to be unique, jump from 88th story, okay? You prove yourself unique, okay? Okay? Then I said, if you survive, you are unique, okay? But nature said you are dead, okay? So now you challenge nature. I don't have to, right? So if you, I think it's so simple that human being needs to have a language. So we create identities. But we need an equation to make sure it's balanced and order. Then we create another view that is from nature's point of view. Now the next equation is actually called category theory. It's the existence of a theory called a category theory. So we prove that there exists a theory called category theory. And that is the third line, and I call it theory of human actions. Now, basically what is category theory is about mapping. It's about mapping. Now, instead of looking at things as things, we look at things, we don't look at things, we look at the mapping. So that we can remove our self-centeredness, we can remove our opinions. Because why you need to look at things? For example, what is one? One is drawing a line to a number called 1. Okay? So you draw an apple, you draw an orange, you draw yourself, you draw a donkey, you draw anything that is still 1, right? And that identity disappeared. Means that bias of it must be you, it must be a cow, it must be an apple, it must be an orange. So now you can compare oranges with apple because they are all 1. Right? So now you can draw 2 lines, 2, draw 3 lines, 3. Okay, you draw a lot of lines, then you happily drawing lines, then after that you run out of space. Well, actually drawing lines is very powerful. If you look at, we draw diagrams, fish bone diagrams and so on, and you look at electric circuit board, you'll be surprised it's only 2-dimensional. Okay, it's only 2-dimensional, and yet it produces your television, your computers, your handphones. It's 2-dimensional, and so you'll be wondering why.
Sir, can I ask you to wrap up, sir?
Okay, in fact that is wrapping up already. Okay, because now we are passing through 4th Industrial Revolution. Oh, it is a new equation. Yes, it's tough to understand, but the good news is the equation exists, and I won't talk too much about equation. You can ask questions about the equations. It's more meaningful that way, and that is where we conclude, because we get through the easy part, coming to the most difficult part, which is the 4th Industrial Revolution, which are these equations. Of course, it has to be tough when the equation is written in 2006. In fact, a lot of mathematicians has not seen this equation before. Okay, so of course it has to be tough. Of course, it cannot be talked further. Of course, we have to end the talk, right? So now is about time to ask the questions.
Thank you, sir. I think you heard really a very inspiring, very dazzling talk. I could see everybody extremely interested, and now is the time for a few questions. We started a bit late, so I'll have time for a few questions. Anybody will want to ask a question? Please put up your hands, identify yourself, and ask a question.
Me from Kenanga Investment Bank.
Yes.
Thank you very much, Mr. Goh, for a very stimulating, at the same time a bit confusing for me. And but this is good. I mean, it really helps to give us a jolt in terms of our mental capacity. My question is, I found out that you are very passionate about, from your presentation, that you are into pursuing the higher order of or symmetry. right? Or asymmetry. But in this world that we are right now, we is constantly facing how you call it, chaos or asymmetric, yeah. And in order for us to go to the next level, we have to go through the chaos, hidden asymmetries, and all those things. How in your view, or in your way of thinking, for for a country like Malaysia, and how you would advise the government in order for them to um, go to the next level. You're talking about digital fourth revolution and all those things. How do you advise the government in order for them to ensure that create the mindset for the whole country to go to the next level, to achieve the higher order for us to advance? Thank you.
Thank you.
Okay, we have actually a very simple answer, but it is very difficult to accept. So, finally, what is economy? Economy is actually a aggregation of everyone's capabilities. Right? No capability, no economy. Now, if you cannot plant, nothing will grow. If you cannot row a boat, you can't row a boat. Now, if you cannot play golf, you cannot play golf. I mean, I thought it's as simple as that. No capability, no economy. Now, and of course, economy is the aggregation of capability, which we call capacity. Now, of course, you can measure capacity by its cohesiveness. Now, it may not be cohesive, right? And so, I can give you two examples of cohesiveness. One is water flows into a dam, and underground water flows into a dam, and it's so natural that a dam is formed. And when we look at a dam, Kenya Dam, we stand there and we say beautiful, and we never ask any question, why? So why water accumulates? Why water aggregates? Why is it because water talk to themselves and then they decided to aggregate or accumulate, or there's a kind of order that leads the water to come to itself, come together, and we call it cohesion, to act as a united whole. But on the other hand, God somehow likes to play jokes, and it makes natural life completely not cohesive. So sunlight is not cohesive. If sunlight is cohesive, we are all dead. Okay, these lights are not cohesive. If these lights are cohesive, we are all dead. Because when you put all lights in phase, it's called laser. It burns you through. Just a thin laser kills you. Okay, and so somehow God likes to give us a lot of fun. And on one side, He gave us an example of cohesive, simple cohesiveness. Water flows into a dam so easy, to the extent we never ask the question. He gave us another problem that we need quantum physics to understand what is cohesiveness. And you need an equation to actually ensure that lasers is cohesive. Now, so coming as a collection of people, it is not difficult. It's a collection of capabilities. And so it leads to something called capacity. But don't forget that we don't live for money. We live for our own purposes. So question is, what do you want to measure yourself? If you use money, one measurement. Are you happy to measure yourself with just money alone? Now, if you are not clear about what measurement you want to measure yourself, and in fact, there's no answer to the economy, then we get que sera, sera. Whatever will be, will be. Okay? So now, of course, people say, okay, let's measure using money. Oh, now we got another headache. Now we got this question about what is money. Right? So what is the money? Money is a mapping, so it's a categorical existence. It is very difficult. That theory of money in economy, I think if you read them, most likely you're going to get more confused rather than getting more enlightened. But I think recent development in international happenings shows that money is actually very convoluted, that it is actually very difficult to say whether high currencies is good or low currencies is good. Now, people in the newspaper talk about, oh, our currency is going down, so country is going down the drain. Well, when Japanese has a low currency, they were the strongest. When they have high currency, they went through economic crisis. So what is strongest? Well, nobody knows. Right? Using simple words like, oh, our currency is falling, therefore we are shit. No, true, not true. Now, example, the current trade war, China versus US. US raised 25%. What if renminbi came down 20%? It's effectively the same thing. Right? 80 times 1.25 is about exactly 100%. So if renminbi came down 20%, actually Trump did all the things, then his tax people has to be busy overnight collecting taxes, and then everyone has to submit forms for non-productivity work, yet the Chinese did nothing, but just let the currency depreciate. And of course the currency will depreciate because God says so. If you don't export a lot, your currency depreciate, right? It's automatic. Now, so first of all, I answer the question by, in economy, we have to look at what we want. Okay, and so we should focus on capability and capacity. And how can we do that? Actually, we have a website. We created a database with Utah about 12 years ago on new villages. Why? Because Karting asked me to help, so I did it for him. Now, actually, our purpose is to map capability and map capacity of every villages. Now, we have extended to some non-Chinese villages. I have raised it to Dr. M that we should actually make sure every villages is registered. Okay, in terms of capability and in terms of capacity, so that we can at least measure ourselves on our capability and on our capacity, irrespective of whether we are going to do anything or not. If we are not going to measure ourselves, then you ask me this question, I can't answer, because there is no measurement. Now, so the first thing, we must have measure our capability and our capacity, and that can be easily done. We have built that model. We have done it for all new villages. We have included, I believe, Inku is there. You can ask him. I believe we have included a lot of non-Chinese villages. We are asking the government, make sure add everyone in. Okay, but of course, you are always having different ideas and so on, and you know, the last thing is to try to push anything, right? So let God take His own time. I believe finally everyone will see it's so important to have a measurement on capability and capacity so that we can decide what we want to do. There's nothing wrong to be a fisherman, you know, relaxing in golden beaches, you know, enjoying the monsoon rain and, you know, trade winds. And there was a joke in IBM when I was there that a New York fund manager told a fisherman to, you know, actually do this and that and you know, buy more boats and, hatch and then borrow money to catch fishes. So the fisherman asked him, so after that, what? And he said, okay, then you list your company in New York. So after that, what? Then you can relax near the beaches. He said, I'm doing it now. Right? So sometimes you have to ask yourself as a human being, what actually you want. Sometimes, like for example, why am I in Malaysia? Because I just want to relax. Right? I don't want to be famous. Don't need to make me famous because don't ask me to cut ribbon. I find stupid to cut ribbon. Okay, and all the way 2-3 hours traffic jam, cut ribbon. Hey, can I do a virtual cut ribbon? Okay, my friend want to appoint me in Hilton Group as a director. So a lot of people will be excited. Hilton World Group, director. So I told him, no problem, I can be your director, but provided that we always do direct conference call. Okay? I said I won't travel to US, go 7 days, come back, to and fro, jet lag, attending a board meeting. Sorry, no. Okay? Answer is no. But we can do direct conferencing call. All the directors voted no. Okay? Thank you. Then sorry, we can't do it because what I want, you are not willing to give it to me. Then I can't do it. Now, so life is not just about money, not about fame. Sometimes it is about yourself. It's actually not sometimes, all the times it's about yourself. And I'm not sure Malaysia is that bad. I'm very not sure Malaysia is that bad because I've lived in New York, Missouri, London, Japan, everywhere. I don't know why Malaysia is so bad. Well, there's some noise. We like to make noise for whatever reason. We somehow can tell stories. We have all kind of fancy. Our WhatsApp is the most busy WhatsApp. And don't know what the heck we are doing. But I think maybe it's very enjoying. That's why people enjoy WhatsApp. But whichever way, I think to talk about economy, you must always have a very specific purpose.
So
how are we going to make money?
I think we have run out of time.
I hope I carry some answers to that. I hope I give you the answer. Now, without a purpose, without measurement, actually, we are not able to get an answer.
Yes, sir. Thank you. So I'm sorry we had run out of time because I know you can talk till the cows come home. But I always thought that the only people who can confuse an audience are economists. But now I know even mathematicians can confuse an audience. But I think that we all enjoyed this talk, and I think Mr. Goh Ping really is an extraordinary man. I do not know how he manages 128 countries in 100 over countries, but I think he's done it, and he's a very successful businessman. Really, I think really we are fortunate to have him with us. And can I ask you now to show him our appreciation in the video. Thank you very much, Mr. Goh. Thank you so much. Thank you.
Thank you, Mr. Goh, for such an enlightening speech. I started off being confused, but I ended up being enlightened. I got that, so that was pretty good. Okay, anyway, I would just stay on stage because we would like to give you a token of appreciation, which will be given by Yang Berbahagia, Tan Sri